What's up, guys? Welcome back to Vanover Machine and Repair, and today's video is going to be a really exciting one. We have three components off of a Caterpillar 963C that we are going to be repairing. So these three components are on the undercarriage of the 963 loader, and basically they kind of hold some mounts that help keep the track nice and aligned. And these holes have been properly wallered out, and it's our job to come in and weld and bore these guys out. So today we have a lot of cool stuff. We're going to be doing some line boring over on the Radial drill, so that'll be nice and interesting. And then we also have some brand new products and designs that I've designed for doing this job that I'm going to kind of showcase and demonstrate. We'll see how good they are and what needs to be changed and modified. But let me bring you in close and kind of show you more detail with what we're working with. Taking a closer look at these two units, they are the worst two out of the three. Both of them have significant cracking. Might be a little hard to see on camera, but we have a crack here and here. And this one here is actually cracked all the way down and around. If I hit this with a hammer, this corner piece would actually chip out. So we're going to start off with these two because they're going to take a little bit extra work. The customer has so graciously provided us all the original OE cat bushings. These bushings will be pressed in from either side and have a hole for our grease fitting. You can kind of see that this is a loose fit on these bushings on that one, and this one kind of drops through. Same thing on the seals. So the first order of business is to get these power washed. These aren't too dirty, but I want to really see what I'm working with. So off camera, I'm going to go and get these cleaned up, and then we'll bring you back and talk about our plan of attack. Now that these are cleaned up, we're going to go ahead and talk about the game plan for how we're going to get these guys bored, fixed, and back to our customer as quickly as possible. So there's really two ways to do a job like this, in my opinion. You can either line bore these, which we did in a past video using the Sur Mechanica setup. It would work very well. However, with the setup time on each one of these, I think it's going to just take too much time when we could do it a little bit more efficient. The second way is to do it on a stationary machine tool. A boring mill would be perfect. My boring mill, unfortunately, isn't ready to go. That leaves the milling machine as the next best option. Now, with the weld buildup and removing it and putting it back in the milling machine and the overhang for the boring bar, I don't think that's going to be the most efficient, so we're going to be trying these on the radial arm drill. So first step is to come in here and get these damaged ones fully V'd out so we can get them fully welded up before we even do any more cutting and boring, and then we'll go from there. Before we weld these, we're going to preheat the parts. You can do this just as easily with a torch, but the benefit of an oven is I can get these in here. I can get them up to a nice and even temperature. I can prep the next step for welding and do other work and then come back and pull these out. So we're going to get the parts in here, let them soak for a little bit, and then pull them out once they're nice and even. Let's get this baby opened, go from there. We're gonna let this soak for an hour or two and then come back when these are up to temp. I checked the parts with a heat gun and they're about 400 degrees, so we're gonna get these out of here and get these welded up. I'm using some of these furnace gloves so that way we don't get burned. I don't see any cracks, so we're looking really good. We're going to get these flipped over, and with them warm, we'll get them welded out. And we're going to MIG weld these with just some regular MIG welding wire. Because we have a ton of preheat, we don't need to run super hot. Lay down some passes on the backside, and then we'll get them back in the oven. While I was waiting for these to warm up in the oven, I bent up a piece of copper, and we just have it clamped in here. That's going to give me a nice backer when I weld this out. I'm not going to be welding too hard. But it'll give me some support as I build that up, and then we can take the clamp off. So we'll come in here and get this welded out. All right, we got this weld built up. I'm gonna let it cool for a little bit and then hit it again. I don't want it to get too hot. And then once it cools down, we'll hit it again and then we'll get it back in the oven and then we'll kind of go from there. All right, we got this fully welded out. We're gonna get it back in the oven and let it cool down slowly. We're gonna work on the other one while we're doing that. We got this one welded out, back into the oven, and we'll come back tomorrow to start working on the bores. We've let these cool overnight, so let's get these guys moved over. Yeah, nice and cool. Parts have cooled down, and we're going to come in here and knock off these copper pads and just grind up the backs, and then we'll get it set up over in the radial drill so we can start boring these guys out and prepare for welding. We don't need to get this perfect. We're going to line bore this. I'm just trying to get the high spots off so that way when we line bore it, we're less likely to break a cutter. That's good. We'll move on to the next. We got the faces on all three of these cleaned up, and we're ready to get it over on the radial drill. Now we could have just come in here and cut the inside and then welded from the back side, but if you really want a nice full penetration weld, you really want to weld on both sides. And so by welding on the back first, we can come in here and bore this out and clean it up and make sure both of our welds are contacting each other, and we get a really nice full penetration repair. A little bit extra work to do it this way, but I think in the long run it'll be well worth it. So let's get this set up on the radial drill. We got our parts set up in the radial drill, and I know I'm going to get questions on this, so I'm just going to take a second to explain it. So you can line bore with a radial drill, no problem. The main thing is just bearing supports and where do you place them. This job is relatively straightforward because it has a really easy mounting flange, and we already have indicated in the table and we know that it's square. This piece is slightly bowed, maybe, I don't know, 1/16 to 1/32 or maybe half a mil. And so it isn't perfect, but it's good enough for what we're doing. So as far as tooling setup, we have a 1 1/4 bar. You've seen me make a 1 1/2 inch bar in another video. That one has square holes. This one has round holes. And then as far as centering the bar on the bore and getting it lined up, I'm trying something new, and we'll talk about this more in the future, but I acquired a 3D printer, and I thought it would be a perfect opportunity to make functional parts that don't need to be metal for different applications in the shop, and this is perfect. So I printed up this centering cone. I figured out that this bore was 3.5 inches plus a little bit because it's slightly oversized. I measured it, and it's somewhat worn consistently, meaning it's not completely egg-shaped on one side. So I printed out this spacer. So this spacer is only here for alignment. So plastic is totally fine. It's a nice, decent fit. And so this is going to help us get the bar centered so we can bring this guy down and make our adjustments. And you can see that this isn't sitting flush because we have some weld, so we're going to push it up. There we go. See the difference? All right, so we know with enough precision that this part is requiring that we're in a really good spot there as far as being centered. So this position is going to be fixed. We're not going to do a bearing support on the top because we have our quill and it's a real short bore. So what I'm going to do now is take a bearing support and place it on the back and fab up a quick mount and secure it. And we'll use that for all of them. And then we'll just use this plug to center all of these up, and that's going to be more efficient than using the cones, and it drops down and registers on the bore with a decent fit, so that'll be perfect. So let me get that set up and we'll come back. Got this plate jammed out. Obviously I need an annular cutter of the right size. That would have been more efficient for the center hole, but we got it done. Went with 1.5 inches, so we had plenty of clearance for the 1.25 bar. All right, we're ready to give this a whirl. We got everything clamped and supported. And just in case we get a couple questions, we're driving the bar with a custom-made Morse Taper 4 tooling to a 3/4 Welding shank. I made this bar with a 3/4 Welding shank similar to an annular drill so we could drive it with the mag drill. I went ahead and set the boring bar diameter so we can take a nice healthy 1/16-ish pass. Ideally, we'd have a second bearing support at the top. However, we do have quill bearings in there as well, and we do have everything clamped. So it might be completely fine, but if we do have some chatter, then we may need to do a top bearing. So we'll just see how it goes. Other than that, I'm going to start out at 144 RPM and the lowest feed rate, and we'll see how it does. Six thousandths on this machine is the lowest. I'm wondering if we have some bearing material in there. These inserts are pretty tough, but they're also pretty expensive. And it kind of seems like we have some hard spots in there. I'm wondering if it's bearing material. So we're going to swap this guy out. It didn't chip, but it chipped out slightly, and we're just going to put in one of these inserts. They don't cut as nice, but they're better for these tougher materials. So we're going to see if we can just kind of cut it out. It's very likely that we have some old bearing material in there, and we want to get rid of all that and clean up that backside. Let me show you how we're going to advance this tool and measure it. We've got a new tool here that I'm working on. Comes up on the bar. Just uses some magnets to come onto the tool. And our bar looks like it was loose. Wow. We're going to advance it. I'm going to take another 60 thou per side. Slide my tool over. Either I forgot to tighten the insert, which is shameful, or it backed out. A little bit unlikely. All right, so we're taking 78 thousandths. I switched out to a different insert. I don't know if that was loose. If it was loose, I don't think it was loose. It wouldn't have cut as much as it did, but I don't know. We'll see. Maybe I loosened it and forgot afterwards. Either way. Might be a little bit hard to see, but we fully reached our weld buildup on the back where we filled that in. We have a little bit of copper here, but I'm not going to keep cutting it bigger to get rid of that. It's just a slight piece. So I'm going to get in there with a die grinder and clean it up until we get down to clean weld. But 95% of this area is nice and clean with no inclusions. So I'm going to get in there and address that, and then we'll get this welded up. I'll pull the bar out. We're welding it by hand. And then we're going to come back here and finish boring this out. We got this fully welded out by hand and it's looking pretty good. I went ahead and did 2 passes. That should give us plenty of meat to cut out. And then I did a ring around the top and around the bottom. It's probably unnecessary, but I'm just doing that. It's better to have a little bit more material and just machine it off than to wish you had some later in the process. So I actually got to head out for the day, so we're going to get this wrapped up, let it cool slowly, and then we'll come back in the morning. We'll get the bar in here and we'll get machining on this one, and then we'll start rock and rolling on the other 2. All right, it's the next day and we're ready to make this cut. I had to mess around with the boring bar. Lessons learned, I'm using a mild steel bar. The bar gets scratched up. I'm gonna switch to a hydraulic bar in the future, but this is what we got right now. The chips get packed in here and the bearing surface is harder than this, and so it scratches that up. So a hydraulic bar or induction hardened chrome bar would probably mitigate some of that. But anyway, for now, we're gonna come in here and make our first pass and clean it up and see how we're looking. Come in here and adjust our tool height. Using our tool height setter here. Another 60 thousandths. So we're at 69 thousandths. Actually, I'm going to take a little more. Let's take 90 thousandths. All right, we got these 3 done, welded out, bored, and cleaned up, and they are looking good. Measurements wise, each one of these is within 5/10. Our bushings here are 6/1000 oversize, and these bores are between 5.5 to 6/1000 undersize, which is perfect. Overall, we had a ton of issues doing this, which we will get more into at the end of the video. The next step is going to be pressing in these bushings. Ideally, we would be using a hollow cylinder jack, which I do not have, which is another issue that we're going to run into. However, I do have some threaded rod that I purchased for that, and I'm hoping that because these are thinner, the threaded rod will allow us to get these in. If they won't, we'll have to come up with another solution, but we're working with what we have, and this job has been difficult the whole way, so I'm sure it won't hold up on us even till the end. Also worth mentioning, I did drill out the holes for the grease fittings. Those were also pretty difficult. I went through multiple carbide drills, but we got those drilled out in case anyone was curious. So on to the bushing pressing. All right, we're ready to press in these bearings. Here's our setup. We have a 3D printed pressing cone. If this breaks, no skin off my back. I'm trying something new, trying to see if it'll hold up. And we just have a threaded rod. We're using a Milwaukee 1/2 inch with the big battery, and we have these huge 1 5/8 nuts. So let's see what we can do here. Okay, that's a good sign so far. Okay, look at that. Plastic's holding up. So far, so good. I'm impressed. I'm very impressed. We got the bushings pushed in. Last thing to do is install the seals. I noticed I didn't get these perfectly aligned. I just kind of eyeballed it. On the next one, we'll make sure they're a little better aligned. It shouldn't matter. It's not worth pressing them back out. I do have a clear shot for the grease to go through those holes, and that is what matters. For the seal driver, we have another 3D printed part here, and so this will just slide on here, and then we'll be able to tap it in. We should be golden. Look at that. Look how nice that looks. Very nice. All right, we got these bad boys done. I went ahead and pressed out the one where the holes weren't lined up. I just wasn't happy with it. So we got all these where all the holes lined up with the grease ports, and everything is looking nice. Now I wanted to take some time at the end of this video to talk about the realities of doing this job. So we're probably going to talk here for about 10 minutes. So if that's not your thing, the video is pretty much over here. But I want to talk about the stuff that I learned doing this job because I got my butt kicked. And I'm not afraid to admit that. That's how we learn, and that's how we get better. And doing line boring work is something that's new to me. And I've done it 3 times, and I've done it on different pieces of equipment every time, and so I'm learning, and there's going to be a lot more of that work to come. So I figured I would take some time and share with you what I've learned through my many mistakes getting this job done. And we did get the job done, and the job turned out great. It just took a lot longer to get there, and there was a bunch of unnecessarily struggles just from not knowing and learning and kind of Forrest Gumping my way through it. So the first thing, and I'm just going to kind of break down each process we went through and what issues that I had. So centering the holes was a little bit of a problem. So I made these 3D printed plugs, which we'll talk about a little bit more, but this one is a centering cone. On one of these, this worked excellent. And frankly, it kind of worked on all of them. It pressed in nice, it did center the bar in the hole, but the issue with these parts specifically is I can't really find a good reference. Now I know there is a rim around the back if I flip these around, but it's cast, and sometimes when it's set up like that, it may not be centered on that ring, and there's really no good place to measure from. So if you guys know of anything, just post it down below so I can learn. But basically the best thing that I did was I took the one that was the least worn, I used the centering cone, I kind of double checked with the outer diameter of the casting, and I went with it. And I just don't know of a better way to get it done. I really would have loved to be able to know with 100% certainty that the position is accurate. When I was handed these, I was told that it didn't matter too much because these holes are bolt holes and there's a little bit of wiggle room, and you know those pins are probably a little worn, but you know, I like to try to get it straight up. So that was kind of the first issue that we had. What is nice about this job is they are flat on the bottom, so squareness wasn't an issue, and setting them up on the machine was really convenient because of the way that all of this is set up. I could literally just bolt it up and just make sure it was square, and that's really easy. So that was the first thing. The second thing is the radial drill, not really a good tool for this. Now the radial drill is a good tool for boring under certain circumstances, and it can do it. We did this job. But really the main thing that I struggled with was rigidity and feed rate. So on my radial drill, it is set up with the minimum feed rate of 6 thousandths per rev, and it goes all the way up to 20. That is excellent for drilling holes. You got big drill bits, you can run them at 6, 8, 9, 20, 25 thousandths feed rate per RPM, and it's perfect. But for boring, it's a little fast. When I had a good cutter and I wasn't cutting anything problematic like bearing material, it worked fine. But anything that was extra hard or was too aggressive of a cut, it just wasn't having it. And so that's kind of something that I don't love about that machine, using it like this. It's not the intended purpose for that machine, but it does do it. And if you look at a lot of the radial drill catalogs back in the day, they show boring setups. Some of these came with a lower range feed box, and depending on how you set it up, you certainly can do it. We did do this job, but my drill just really isn't set up super well for it. Now, after the fact, I realized that I could have moved the head closer to the column. That would have probably given me more rigidity, but hey, you know, we live and we learn. The next thing is removing the old material was extremely difficult. And just to give you some context, this is my third line boring job. The first one, I line bored cast iron on the arbor press. There's a video of that. The second one, we did line boring using a WS2 on a boom stick, and that was mild steel most likely. And in comparison to those two jobs, this was way, way worse. And so honestly, the easiest one to cut was the one that I had to do the most weld repair on. The one that I thought was the best one that I saved for last actually was the hardest, and we broke an entire boring bar, and we went through about 10 inserts on this job. And I think a lot of that has to do with movement in the bar. I was using an 1.25 inch bar, which I have right here, and that 1.25 inch bar, honestly, I think it's too small. I think the bar was flexing even though my bearings weren't too far apart, and I think that was causing some inserts to break. Obviously the machine had some flex, but adding that bearing at the top did help with that. So between the bar being a little small and the machine not being super rigid, and I think because of the way that these were set up, there was a lot of like maybe bearing impregnated material, or maybe like, you know, someone tried to weld it up with a really hard rod, but there were some really hard spots. And visually there was no bearing in there when I got these, so it's not like it was obvious. But a couple of these were just really hard to cut, and that just really sucked. I just had to go slow, and I just went through inserts. I used some crappy inserts just to, you know, kind of get through that, and once I got through that, it was mostly fine. But it was, you could see when you were hitting that, you could see the radial drill kind of flex, and it was a big pain in the butt. I didn't show a lot of that on camera because I was just struggling, and at the end of the day, I want to get a video out for you guys on this, but there becomes a point where filming just gets in the way and you need to be able to kind of just get it done, and we need to get this job done. So I just tried to show you some of it, and I'm kind of coming back to give you some dialogue on that. So the bar. So I used a mild steel bar that I used when line boring the arbor press, and terrible idea. Obviously that seems pretty obvious in hindsight. All the boring bars out there for line boring are chromed, but when you look around, chrome is not readily available, meaning it's not laying around, right? If you're a hydraulic shop, it probably is. But when I needed to make the bar for that job, both for the arbor press for line boring it and another line boring job we did on the horizontal K&T, which wasn't really line boring, but I made the bars with what I had, and they worked fine for that. However, the issue that I ran into was when I was cutting this really hard material, it wasn't really creating a chip because I was having to go with a minimum depth of cut, and it was hard. So it was sparking, and it was producing a lot of fine, hard dust, and that dust was falling down onto the lower bearing, and it was scratching up the shaft of the actual boring bar, and it just made it a nightmare. Literally every time that I would do a cut, once I finished up, the bar would be real tight to move up and down. I'd have to hammer the bar out, and I'd have to take it over the lathe, and I'd have to polish it, and it would have all these drag marks from hard material that got trapped between the bearing and the bar, and it damaged some of the inside of the bearings, so I had to like flap wheel those out. And as I moved along, it got a little bit better and better as I kept an eye on blowing air off the bearing mounts and trying to be a little bit more eager with the lube and several different things. So towards the end, it got better. In hindsight, having the bearing below, probably not the best case. Probably should have a cover or something keeping all that dust off the bearing, kind of like you do on a steady rest when you're machining, keep the chips out of it. But it was a nightmare. And I don't know how much of that you guys caught on to, but yeah, it sucked. I probably had that bar in the lathe maybe 5 or 6 times. So we're running into a lot of issues, but I'm making notes not only to share with you, but for myself, so that way in the future, we're going to do things differently, and we'll talk a little bit more about that. But I would not recommend, if you're going to do any serious line boring and you're using a homemade setup, I wouldn't recommend just making, I think this was TGP or turn ground polish, so I didn't cut the OD. It was dimensionally accurate, but it was mild steel. Just go and purchase hydraulic rod in the right size, and it sucks to drill, but do it. There's an advantage and a reason why they do it that way. Welding. Welding actually went pretty smooth. I thought it would be a problem. You've seen us use the oven to do a little preheat. Not necessary at all. I did that because I have a bunch of things going on in the shop. I got that oven for another job, long story, and I wanted to use it. And I thought it would be an excellent opportunity to get these parts in the oven, bring them up to temperature consistently, and let me do something else and then pull them out. So it worked really well for that, kind of to save time, and I think it allowed for us to get a nice repair, especially on the 2 that were cracked, and know that everything was nice and heated properly. But anyway, the point I'm trying to make is welding went relatively smooth. Using a bore welder would be better. I do have access to that, but just setup for this, it would have been too much work, and hand welding these went fine. I actually used my smaller MIG welder, and it worked out really nice. I was able to run some really nice hot passes, and I did 2 rounds on everything. I thought I was going to get away with 1 on the one that wasn't too badly worn, but I ended up doing 2. It's always better to have a little bit more weld than to come back and realize you got a bunch of inclusions from trying to be skimpy. So overall, the welding went well. No real crazy stuff there. Measuring. So measuring these out was a problem. Now, when I did line boring last week, I was using a WS2 and I was doing a boom stick, and that kit has those little snap gauges that you've seen Curtis and other people use. those work pretty well, and that's what I used. It's nice, you can get it into the bar, you can get an accurate measurement, and continue on. And from doing that, I basically kind of invented / came up with this tool in front of us as a option or a alternative to the Climax version of this height gauge. And we can get into more of that in another video, but the Climax tool setting height gauge is several $1,000s, and I wanted to see if I could create that for an 1/8, a 1/10 of the cost, and that's what we did. I 3D printed some parts and modified the height gauge. That worked pretty well, but the reality is this style of measuring works really well as a reference measurement, meaning you can measure the bar, measure off the base and all that, but really it's best to take a cut, measure it, and sort of advance the tool based on that, because there's going to be deflection in the bar and all these variables. And so insert wear, by doing it as a reference measurement, works pretty well, and this works well for that, which is a win. But my problem is I had no way to accurately measure the inside of the bar without taking the bar out. Now, I did use some snap gauges. It's a kind of a trick you can use between a snap gauge in the bar and the snap gauge in the bar on the other side, and then measure the bar and add them together. That's the technique I used. It got me close, maybe within 2 or 3 thousandths, but I really didn't want to chance it. So on the end of all of these, I pulled the bar out, which is a pain in the butt. I took a measurement, confirmed it, and then put the bar back in, had to redo all the tool setting, and overall we got it. Pretty much all of these, I think 2 out of the 3 came out within 1 thousandths or 2. One of them was like 4 thousandths under, and then I had to flap wheel the under one a lot more than the other 2, but I'd rather have that be the case than overshoot it. So it was a little much more of a pain. I can't decide if I'm going to make some of those inner bar snap gauges or what other methods I'm going to use. I do have an in-size caliper, and I found towards the end that's pretty dang accurate, and so I started to trust that a little bit more, and it can kind of sneak in there, but it was a challenge. All right, let's see. Grinding on the back side of the holes was a pain in the butt. So as you've seen, I had these set up kind of in this orientation, and what that allowed me to do is just kind of see where I'm welding really nice. And on the front, I had a really nice ability to kind of weld around the perimeter and get a pretty clean facing cut by doing some step facing, which is cool. But on the back side, as you can imagine, it was really tight on my bearing housing, and it wasn't until the last one where I realized I had enough room to sneak my cutter and sort of step face the back. So on 2 out of the 3 of these, I basically had to kind of grind inside of this pocket to level out all my weld runoffs. And then once that was ground, then I threw another pass and ground that down. Just because you're in a hole here, it's kind of a pain to grind down there. And so I was using a 2-inch disc and a roll lock and all kinds of stuff. We got it done. It was a pain in the butt. So I need to come up with some better solutions on that. I don't know how likely that is to occur in the future, but it's not like you can just get a grinder up here and grind this. Could I have flipped all these back over and step face the front? Yeah, but I think it would have took more time than grinding it. So it was just, unnecessary struggling with that. Drilling out the grease fittings. The last one that I did on that excavator boom, I drilled out the fittings, no problem with a standard drill bit. But these ones, I think it's, again, because of the way they failed and the use case, they were super hard. I started with a normal drill bit. That had no chance. I actually drilled all 3 of them out with a carbide drill bit, but I went through a couple different carbide drills, and it was a huge pain in the butt. I don't really have a good set, so I was kind of using, just random sizes that I have. They do work, but they were breaking, and I had to sharpen them, and I need some tooling that I don't have. That's the moral of the story. But for whatever reason, I think some bearing material was caught in there along with the weld, and it was a literal pain to drill these out. But we got them drilled out, and they're good to go. And then pressing in the bearings. Let's talk about that. So I was really kind of worried about pressing in these bearings because the right way to do this, either on a hydraulic press or what most guys have, is a hollow cylinder jack. I don't have one. I'm probably going to order one after the job, so it'll be good, in the future. But I was worried that with a 5 or 6 thousandths press, it was going to be too hard to do with my threaded rod setup, but it actually worked out fine. And I was able to use a threaded rod, and I was able to use the arbor press, and the force to get these in was sufficient, meaning that they were tight. They're not going to go anywhere, but I think because they're only a 1/2 inch wide or 3/4, that really helped. It's not like I'm pushing in like a 3-inch sleeve. And so I think I got lucky on this job, but I think the next jobs we're going to need to get that hydraulic hollow cylinder jack. So yeah. So overall, and then let's talk 3D printed parts. So we're gonna do a review on 3D printer stuff later. I'm just messing around right now. But we got 4 things in front of us that I 3D printed specifically for this job. We already kind of touched on this. It works pretty well. I need to make some modifications to it, but overall, helped us measure accurately. We had this guy, which is designed to basically take a threaded rod and push the bushings in, and they kind of were a nice fit on the bushing. Why plastic? Well, I thought it would be cool to see if we can make these out of plastic, because then they can be made more efficiently than machining them, and obviously keep the cost down. And I could crank out a bunch of them for different sizes. To be honest, this one worked out great. I put it under a load of pressure, and I don't see any deformation, and looks great. I had it over on 25 tons on the arbor press, no problem, and whatever the tonnage is, squeezing these. So this one, pretty successful. I think what I'm going to do is I'm going to make them a little bit thicker, add up the infill a little bit more, but for the most part, I'm pretty satisfied. This is just PLA plus with 50% infill, and I think it's a grid style infill. The seal driver, again, deformed a little bit, but I was actually using it as this one accidentally. So I think I need to beef this up. But as a seal driver, it actually worked fine. Seals don't take a lot of force to push in, and it worked really nice for that. These are nice because it allows you to get centered on the seal and be able to tap it or press it in. And it's really cool to know that I could print these in different sizes and have them, as opposed to trying to beat on the seal around the perimeter. It just allows you to get a more professional job. So this one I'm going to, improve a little bit, but I abused it, but at its intended purpose, worked pretty well. And then the centering cone actually worked surprisingly well, but yeah, I mean, there's limitations with centering things accurately with a cone, either this style or another cone. I have some 3D printed actual cones, but those are only so accurate. So that's the 3D printed parts. All right, let's talk about the difference between line boring with a mag drill, line boring on the horizontal milling machine, I guess, line boring with a WS2, and then on the radial drill. So just real briefly, the first line boring job we did, I actually did on the K&T. It wasn't really line boring, but it was fine. I just made a boring bar and did some line boring cuts. No big deal, it's fine. Second one was the more realistic line boring job. We line bored with the mag drill. Overall, worked out pretty well. The main issue there is the welding, right? So we ended up using a bushing, so it wasn't really a problem. The mag drill works pretty well for line boring, but it has a lot of limitations, both in terms of bore welding and also, feed rate and all that kind of stuff. So that's kind of the lowest common denominator for doing it. I have the setup, but I'm going to try to avoid doing that in the future. As far as the WS2, that's probably the best option. I have access to a WS2. I really like that machine. I've only used it once. There will be more to come of that machine. But overall, it's a pretty good tool. There are some shortcomings of it, which maybe I'll touch on. But overall, using a portable line boring machine specifically to do portable line boring obviously makes a lot more sense than trying to do something with what you have laying around. So it makes sense that it would be much more easier. Now, what I will say is doing a job like this would probably not be ideal with a portable line boring setup, just because you need to do a setup on each of these. and the time to set all those up probably wouldn't make sense if you could just knock it out on a different stationary machine. But I did, after the fact, think about you could probably set these up in a row and put your bearings on the ends of 2 of them and put a support in the middle, and maybe then you could use portable line boring to do it more efficiently, and then you get to use the bore welder, which is really nice. And then lastly, we used the radial drill. The radial drill, like we talked about, it works, got the job done, but there's just limitations in rigidity and on mine, feed rate. And doing it up and down is nice, but all the debris keeps falling down. So it may not be a problem with a better bar, but it's just maybe not the most ideal. The most ideal way for me to do it without doing portable line boring machine would be to use the horizontal boring mill. I think the feed rate on that is going to be a lot more gentle, and we can do it on its side, which mitigates some other issues as well. So I think in the future, maybe we'll be leaning towards that if we're in the shop. And then if we're in the field, obviously we'll be doing a WS2. So other than that, that kind of wraps up everything I wanted to touch on. Again, I'm just kind of reviewing this stuff for learning for you guys and for myself. I just want to say that overall, line boring work is difficult. If you're anything like me, you watch all these guys line bore and you think, that's pretty easy, I could do it. And at the end of the day, we did it, right? And we're going to be doing it more. And you can do it. And I'm sure you can do it too. But like with a lot of things, there's a lot of things that you see that you don't think about. And it's a lot more difficult than it can be. And I think what I would like for you guys to understand is that when line boring is going well, it's not too bad. But I think the difficult part, and this is from a limited experience, but experience on a couple different types of line boring so far, it's the issues that really throw you off. When you're having problems with your welder not welding or porosity, you spend a lot of time fighting whether it's the tooling or whether it's the setup or whether it's issues or details, or maybe you overcut it and then you got to redo it. And so line boring is great because you can make a good hourly rate, but if you're line boring a really long hole and you overcut it and you got to come back and re-weld it, yeah, you're making a good hourly rate, but you just caused a mistake that, you know, might take an hour or two to back up. So I think like a lot of things, once you get good at it, it really is worth it, but the learning curve seems to be pretty steep. And, you know, it is on a lot of things, machining, video editing, all this stuff. But overall, I feel like I've been getting my butt kicked on these line boring jobs because even though I know machining and I know welding, and those things are involved in line boring, there's a whole set of additional skills needed and a whole bunch of booby traps that you can fall into that really make line boring kind of a pain in the butt. So there is going to be a lot more line boring content coming, so I hope you guys enjoy that. And we are trying to move more towards working on this more heavy equipment stuff, so there will be more content coming on that. I know this has been long-winded, but I hope you guys kind of took away and are learning from my mistakes and losses. I know that I'm going to be buying some more tooling, upgrading and changing the way I'm doing things, and hopefully on the next one we'll be in a little better place, both in terms of learning and tooling, and should be good overall. So overall, I'm very happy that we got this job done, and I hope you guys enjoyed the video, and if you have any comments, let me know down below, and we'll see you on the next one.